Throughout the development of our application for the travel agency, we've mentioned the importance of separately testing the new functionalities we're developing, and then testing the entire application to make sure it behaves as expected. As the application grows, this type of task can become increasingly burdensome, so Genexus helps us by providing features to create and run automatic tests. This is in order to reduce some of the manual verification work. Unit tests allow us to test a part of the application separately. In Genexus, unit tests without an interface are applied to tests on procedures, data providers, and business components. In short, on those components where the business logic of our application should reside, and that's why the unit test object exists. The interface test allows us to create tests simulating a user's actions on the browser in order to test entire application flows. For this purpose, there are UI test objects for mobile interfaces and web UI test objects for web interfaces. So, when should a Genexus procedure be tested? When given some input parameters, the output of the procedure is to be tested by comparing the expected results, using assertions, with the results of the process, either output variables, files, or database records. To this end, assertions, that is, affirmations or statements included in the procedure, are used. When there are no input parameters, but from parameters or database settings, the procedure is expected to return some expected results, for example, variables or database records, and when there's a mix of both scenarios. This means that any Genexus procedure can be tested to verify that it works according to the defined specifications. In addition to procedures, unit tests associated with data providers and business components can also be defined. The main benefits of performing unit tests are as follows. To detect errors in the code early. To give immediate feedback to developers. They're fast and shared throughout the knowledge base if Genexus server is being used. And developers can run their tests from the Genexus IDE itself with no need for other tools. Okay, let's see an example. From the Launchpad, we run work with trip and see that we have 3 trips registered with their current costs: $1,100, $1,800, and $2,300. We've created a procedure named update trip price, which calculates the price increase of a given trip according to a percentage received by parameter. For the travel agency, the final price of a trip cannot exceed $2,500. We see then that the procedure receives 2 input parameters, the trip ID variable and the increase percentage. Also, it has an output parameter that returns the value obtained by the increase, along with a comment that indicates whether the update was performed or the maximum amount indicated was exceeded. Then, for the trip ID received, the procedure calculates the value according to the percentage that was also received, and if that value is greater than $2,500, it does not update and returns the corresponding message. If the value is lower than or equal to $2,500, it does update the value of the trip price attribute and also returns the corresponding message. In case there is no trip with the trip ID value received by parameter, a message will be returned indicating that the trip is not registered. Okay, to test this procedure, we're going to create the corresponding unit test. To do this, we right-click on the Procedure tab and select Create Unit Test. Then Genexus creates 3 objects, which can be seen below the New Test node in the KB Explorer window. The Update Trip Price Test STT object, which defines the structure of a given test case for the object we're testing. Note that, as we would do, it defines both input variables with the same name as the parameters of the procedure, and defines an expected update result variable where we'll be able to define the value of the expected result. In short, we'll be able to say, for example, that for the trip ID equals 11, with a current cost of 1100, if we indicate an increased percentage of 10%, we expect a result of 1210, with a message indicating that the price was updated correctly. We can also assign a message that we want to be displayed in case the result is different from the one indicated. Now let's move on to the update trip price test data object, also created automatically by Genexus. This data provider is based on the SDT we saw earlier and allows us to define a data set. By default, 5 test cases are created, but we can modify it. We have 3 trips registered, so we're going to define 3 tests with an increased percentage of 10%. In each case, we indicate the expected value returned by the procedure. But we also define a 4th test set for trip ID equals 8, which does not currently exist in our database. Lastly, the update trip price test object is the one that will run through the collection of test cases. And for each one of them, it will invoke our procedure and validate whether the result obtained matches the expected result. This object is a Genexus procedure and is programmed as such, so we're going to see a very familiar notation. That is, for every test case in the collection of tests that we define in the data provider, a call is made to the procedure we're testing with the input parameters defined in the test case and a variable as output value. What's new in the unit test is the assert command. It basically compares an expected result, defined as part of the test case, against the result obtained. If the expected result and the result obtained are the same, the test is successful and is said to pass. And if there's any difference, the test fails, and an error is reported showing an associated message. Here we're using the assert string equals function to validate the result since the result is a text. But it's also possible to use assert bool equals to compare booleans, or assert numeric equals for comparing numeric values. Okay, to run it, we right-click and select Run Test. Once the test execution is complete, we'll see the new window named Test Results, where we confirm that the test was executed, update trip price test, and that the result was successful because it's marked in green. It also gives us information about the test execution time. Here we see a line for each assert we have defined in our test. For each one, we can see the expected result, the result obtained, and the green or red mark depending on whether the assert failed or passed. We're going to run the test again, but first, we're going to return the costs to the initial state and modify the data provider, assuming that the trip with identifier trip ID equals 8 exists in the database, and we assign it a certain cost. The idea is to generate a failure in this test set because our procedure will indicate that the trip is not registered. We run the test again by pressing this button, and see that a test set failed, since the expected value and the obtained value are different. From here, we can see the comparison between both results. and from here we can run again the test sets that failed. We can also export the test result to HTML. Although we've seen a simple example, as we've already said, we can test all kinds of procedures, data providers, and business components. We can perform much more complex tests, using real data from our application, either in a real or simulated database, and cover the validation of a very important part of our application. The set of unit tests that we build for each functionality automates part of the regression testing and helps us develop a more robust application.